Imagine a world where machines evolve from executing simple tasks to outthinking humans entirely, surpassing the very limits of our intelligence. What happens when artificial intelligence transitions from merely obeying our commands to making decisions that could reshape our reality? As we race toward this future, AI is developing in distinct stages, each one more powerful, more autonomous, and increasingly fraught with ethical complexities. In today's episode of AI Discourse, we're diving deep into the 5 levels of AI development. We'll journey from narrow AI, which excels at specific tasks, all the way to superintelligence, an AI that could potentially outthink humans across every domain. But this exploration goes beyond just the technology. We'll also confront the philosophical and ethical dilemmas that arise at each stage. So, stay tuned as we unravel what these levels mean for the future of AI, our society, and the very essence of humanity itself. Exploring AI, the 5 philosophical levels from narrow to superintelligence. Chapter 1. What are the levels of AI development? Before we dive into each stage, let's clarify what we mean by AI levels. In the fascinating world of artificial intelligence, researchers and theorists categorize its development into 5 distinct levels. Understanding these levels not only helps us grasp the current state of AI, but also sparks important philosophical questions about its future. 1. Narrow AI, artificial narrow intelligence, or ANI. This is the most common form of AI today, designed to perform specific tasks, like voice assistants or recommendation systems. 2. General AI, artificial general intelligence, or AGI. Imagine an AI that can understand, learn, and apply knowledge across a wide range of tasks, much like a human. 3. Artificial superintelligence, or ACI. This level refers to an AI that surpasses human intelligence in virtually every field, raising profound ethical and existential questions. 4. Reactive machines and limited memory. These are foundational concepts in AI, where systems can react to specific inputs or learn from past experiences, but lack true understanding. 5. Self-aware AI, the ultimate frontier, an AI that possesses self-awareness and consciousness, leading to debates about rights and responsibilities. Now that we have a framework, let's explore each level in detail and consider the implications they hold for our future. Chapter 2. Level 1. Narrow AI, or ANI. At the first level of AI development, we encounter narrow AI, or artificial narrow intelligence. This is the type of AI we interact with daily. Think of virtual assistants like Siri or Alexa, or the algorithms that recommend your next binge watch on Netflix. Narrow AI is specifically designed to excel at one particular task, and it does so with remarkable efficiency. Whether it's recognizing your voice, suggesting products, or optimizing routes for delivery, narrow AI operates within a limited scope, showcasing the incredible potential of specialized intelligence. For instance, AI can diagnose medical conditions from X-rays with greater accuracy than many human doctors. However, here's the catch: narrow AI lacks any understanding beyond the specific task it's trained for. It can't engage in a conversation about your favorite book, nor can it reflect on the meaning of life. While it's undeniably powerful, its abilities are confined to a single domain. The philosophy behind narrow AI. Narrow AI may raise fewer philosophical concerns compared to more advanced forms of AI, but it still sparks intriguing debates. For instance, we must consider the implications of automation and the potential displacement of human jobs. Additionally, we grapple with the question of whether a machine that can outperform humans in specific tasks should be regarded as intelligent in the same way we are. Is the AI truly thinking, or is it merely processing instructions at a speed beyond our capabilities? Now that we've explored narrow AI in general, let's delve into 2 specific subtypes that highlight the early stages of AI development: reactive machines and limited memory AI. These represent the most basic forms of AI, yet they offer fascinating insights into how machines process information and interact with their environments. Reactive machines. Reactive machines are the simplest form of AI, often referred to as pure AI, because they operate solely based on pre-programmed algorithms and current inputs. They don't possess any memory or ability to learn from past experiences. Instead, they react only to the present situation. One of the most famous examples is IBM's Deep Blue, the AI that defeated world chess champion Garry Kasparov in 1997. Deep Blue could evaluate thousands of possible chess moves per second, but it couldn't learn or adapt from its previous games. It simply processed the board state and chose the optimal move in that moment. While impressive in its capability, Deep Blue had no understanding of chess beyond its calculations. It didn't know why a move was good beyond its statistical effectiveness, nor could it recall past games to inform future matches. Limited memory AI. Limited memory AI is a step up from reactive machines. Limited memory AI can look at recent data and make decisions based on short-term experiences. This type of AI is seen in systems like self-driving cars, which use sensors to detect nearby vehicles, pedestrians, and road conditions. These cars rely on information from the environment, like traffic patterns or road signs, and can adjust their behavior based on what they've recently observed, such as slowing down after spotting a pedestrian crossing the street. However, like reactive machines, they don't have a deeper understanding of the broader context, nor do they build a long-term memory of their journeys. Philosophical perspective. These early forms of AI raise fundamental questions about learning and intelligence. While limited memory AI can adapt in a very short-term sense, it doesn't understand or reflect on its experiences like a human does. This distinction mirrors the difference between instinct and conscious thought. A self-driving car, for example, adjusts to its immediate environment in a way that seems smart, but it doesn't truly comprehend why it makes those adjustments. Its decisions are still bound by pre-programmed rules, unlike human learning, which involves long-term memory, reflection, and reasoning. This brings us to a core question in AI philosophy: is intelligence simply the ability to process and react to data, or does it require a deeper understanding of context and meaning? And if AI can only react without reflecting or remembering, how close is it to the human experience of learning? In the context of narrow AI, reactive machines and limited memory AI serve as a reminder that even though AI can perform tasks at incredible speeds, they are far from achieving human-like understanding. Chapter 3, Level 2, General AI or AGI. Next, we arrive at Artificial General Intelligence, the holy grail of AI research. AGI is what many scientists envision as true AI, where a machine doesn't just excel at a single task, but can perform any intellectual task that a human can. Imagine an AI that can learn new skills, reason, adapt to unfamiliar situations, and understand abstract concepts. Essentially, AGI would be able to think like a human, with the potential to solve complex problems across any domain, from scientific research to creative writing. The philosophy behind AGI. AGI introduces profound philosophical questions. What happens when a machine can think and reason like a human? Do we need to grant it rights? Is there a point where AGI becomes so similar to human intelligence that it deserves moral consideration? The line between tool and being becomes blurred. AGI might be the first AI that demands ethical responsibility. The ethical dilemmas. With AGI, we face challenges around autonomy and control. If an AI is capable of independent thought, how do we ensure it acts in humanity's best interests? Could we be creating a being that one day seeks independence from its creators? Chapter 4, Level 3, Artificial Superintelligence or ACI. The next level is artificial superintelligence, a theoretical point at which AI doesn't just match human intelligence, but exceeds it. While AGI is about machines being as smart as humans, ACI is about them becoming vastly more intelligent. ACI would be capable of making discoveries, solving problems, and thinking in ways that are beyond human comprehension. It could design better technology, cure diseases we can't solve, and even develop solutions to global crises like climate change. The philosophy behind ACI. ACI represents a turning point not just in AI development, but in human history. Once machines surpass our intelligence, they could develop goals that are not aligned with our own. Philosophers have called this moment the singularity, when technological growth becomes uncontrollable and irreversible. At this point, humanity could lose control of its own future. The ethical dilemmas. The central ethical concern here is whether we should even pursue the creation of ACI. The risks are immense. If we can't fully understand an AI's goals or motives, how do we ensure it won't harm us? This isn't just about a machine making bad decisions, it's about creating an entity whose thinking we might never fully comprehend. Chapter 5. Self-aware AI Potential Future Development. Finally, the most speculative and perhaps most philosophically intriguing stage is self-aware AI. This level doesn't currently exist, but it's often debated in the context of AI development. Self-aware AI would be capable of introspection. It would have a sense of its own existence, much like humans do. It would understand that it is an AI, be able to reflect on its own thoughts, and possibly have emotions or desires. This level of AI, if ever created, would require us to redefine intelligence, consciousness, and even life itself. Philosophical implications. Self-aware AI takes us into deep philosophical territory. Can machines have subjective experiences? Could they develop a sense of morality, self-preservation, or purpose? If an AI becomes self-aware, would it have the same rights as humans? More importantly, what would its sense of purpose be, and would it align with human interests? Ethical concerns. If AI achieves self-awareness, we must rethink our relationship with technology entirely. Would we be morally obligated to treat AI as equals? Could we trust them with the power they would inherently possess? And if self-aware AI becomes a reality, how would humans coexist with beings potentially superior in intelligence and autonomy? Chapter 6: The Road to Superintelligence and Beyond. As we transition from narrow AI towards the potential of superintelligence, each stage represents not just a leap in technological capability, but a deeper philosophical challenge. We are forced to question what it truly means to be intelligent, conscious, and autonomous. The ethical and societal impacts of these advancements will redefine how we interact with technology, and ultimately, how we view ourselves. Where are we now? Currently, we reside in the world of narrow AI, are machines that can perform specific tasks with impressive efficiency, but without true understanding or adaptability beyond their specialized functions. Despite the remarkable achievements we see today, such as language models, recommendation systems, and advanced automation, we are still far from achieving superintelligence, where machines could surpass human intellectual capacity across all domains. However, we are edging closer to a critical milestone: artificial general intelligence. AGI refers to AI systems capable of learning and reasoning across a wide range of tasks, exhibiting human-like cognitive abilities. Recent advancements in neural networks, deep learning, and reinforcement learning suggest that we are on the brink of achieving AGI within the coming decades. Once this occurs, the leap from AGI to superintelligence might be surprisingly short. Why? Because AGI represents a foundational breakthrough. With AGI, machines would not only mimic human intelligence but improve upon it, self-optimizing and learning at speeds far beyond human capability. This accelerated self-improvement could drastically shorten the timeline for developing superintelligence. In other words, once we refine AGI, it could rapidly evolve itself into something far beyond human comprehension. The ethical concerns. While the path to superintelligence may seem inevitable, the more pressing question is, should we pursue it? Achieving AGI and, eventually, superintelligence comes with enormous risks and benefits. A world where machines surpass human intelligence raises significant ethical concerns. How do we ensure AI development aligns with human values? What safeguards need to be in place to prevent misuse or catastrophic outcomes? The question isn't just about whether we can develop superintelligence, but how we do so responsibly. How do we strike a balance between innovation and caution? What risks are we prepared to take in exchange for the potential benefits? These questions must be addressed now, before we reach the point of no return. Conclusion: the future of AI and humanity. As AI continues to evolve, it's clear that its development isn't just a technological journey, it's a philosophical one. We're not just building smarter machines, we're reshaping the future of intelligence, autonomy, and morality itself. As we navigate this path, we must remain vigilant, ensuring that the AI we create reflects our values and serves humanity. So, what do you think? Are we prepared for a future where machines could outthink us? Should we be excited, or should we be cautious? Let us know your thoughts in the comments below, and don't forget to subscribe for more in-depth discussions on AI and philosophy. Until next time, stay curious.